Ooh. Let's see if anybody's going to actually watch this.
Hi, Jojo.
Hey, what's up? Mm-hmm. Yep.
Our members understand social distancing. The longest field goal in the NFL was a 64-yarder kick by Matt Prater, but the longest field goal ever kicked was by a college student named Ove Johansson, a Swede who had only just started playing football that year as a way to be closer to the girl he loved. Ove Johansson, born in Sweden.
Okay. First of all, thank you for your question. I tried to I tried to post, and I'm telling you this because I need you to do me a favor. I'm going to answer your question, but I need you to do me a favor. I need you to go through Moodle and your emails and look for KNES 415, because this is the biomechanics review, and look at the post, the email that I sent you guys, setting the tone for the rest of the semester, okay? And again, it's not, I'm going to answer it, but I need you to be able to know where to access some of that information to make sure there's no miscommunication, okay? So, in addition, I took out my calendar this morning. So, if you haven't watched today's lecture, which is fine, you didn't have to for this session, but if you go back, I actually have my calendar and kind of go over it all with you. So, so our exam is going to be on the 29th, which is a Wednesday. But that is all on the clarification email for grades and everything. And the test is going to be on Moodle. So when is your test? The 29th? Are we having a review? Probably. How is the test going to go? Moodle. Moodle test. First time I've ever given a Moodle test. 17 years of teaching. It's crazy, huh?
Grew up with the American dream twinkling in his eye, which at the time was still a thing. And after a stint in the Navy, he jumped at an opportunity to play semi-pro soccer in Dallas, Texas. It was there, during a soccer match in 1972, that he noticed a young woman sitting in.
Okay. All right. Mallory. Can you explain acceleration in the negative again? I'm confused between velocity acceleration. Okay, what a great question. So, first I'll start off by saying They are both kinematic concepts, so they both describe motion in different ways, okay? Velocity is how fast you're going in a certain direction. So think about the best application of velocity that you experience every day is, maybe used to experience every day, is your car. So your speedometer on your car that tells you how fast you're going, all of those numbers are measures of speed. And when you give direction to it, like on some cars, it'll tell you, gives you velocity, the magnitude with the speedometer, and the direction with the little compass, right? The little directional thing. So what is velocity? Displacement over time. How fast are you going? How much do you displace per unit of time? Or another way to look at it is, how much time did it take you to displace? When your speedometer says 20 miles an hour, that is, you're going to displace 20 miles per hour, per unit time. Acceleration is how much time did it take you to move that needle? That's what acceleration is. Acceleration is how much time did it take you to change your velocity? So velocity is part of the equation of acceleration. Different ways of saying acceleration is change in velocity in regard to time, or how much time did it take for your needle to move. If you're on a road and let's say it's you've been 45 is the speed limit, you've been cruising at 45, and then all of a sudden the highway changes to 65. Your acceleration is going to be how much time did it take you to move the needle from 45 to 65. The change of 20 miles an hour and the unit of time gives you acceleration. And the acceleration that you experienced is going to be proportional to the unbalanced force that accelerated you. So think about car dealerships. They'll do commercials where they want to brag about the acceleration of cars. And they'll say things like 0 to 60 in 4.2 seconds. They're inferring accelerations, because in humans, we don't really talk about accelerations that much in terms of like you talk height a lot, 6 feet, 8 foot, you know what's tall, what's short, but we don't talk about magnitudes of acceleration. So when car dealers want you to know that a car has high acceleration, they literally give you the equation. From 0 to 60, there's your change in velocity in 4.2 seconds. There's your time. How much time did it take you to change your velocity? Okay. So acceleration does not mean to speed up. It just means change in velocity. And because acceleration is a vector quantity, there's direction to it. So remember, Newton says F is equal to ma, not F is equal to ma if you're speeding up, and F is equal to md if you're slowing down. No. So acceleration in the negative means that I have a negative unbalanced force. So remember, F is equal to ma, F directly proportional to ma. We're going to assume m is the same. In other words, the mass of u isn't going to change, the mass of the ball isn't going to change. So really, we're looking at the direct proportionality between forces and accelerations. So negative accelerations are caused by negative forces. And I don't mean like negative, like I owe you force, it's direction of the force. So let's think about a negative force that we experience all the time, gravity, right? Gravity from planet Earth. What's the object? The Earth. So the negative force of gravity is a negative accelerator. It negatively accelerates things because the negative force of gravity is going to yield a negative acceleration when it's the dominant force. So you think about, where's my baseball? So if I toss a ball up in the air, it's going to be negatively accelerating the entire time it's in the air, that it's not touching my hand. It's going to be negatively accelerating as it slows down going up, and it's going to continue to negatively accelerate as it speeds up coming down. Why? Because the whole time it's in the air, the only force acting on it is that. And if there's a negative force acting on it that's influencing its motion, the acceleration must be negative. Negative has to equal negative. You can't have a negative on the left equal a positive on the right. You can't have a positive equal a negative. Negative has to be negative. So if the only force working on the ball is negative, the acceleration must be negative. Yeah, gravity is always negative for us. Um, yes, for the purposes of this class, gravity is always going to be negative, um, meaning the direction, right? Um, Technically, in biomechanics, you could always define things how you want it, but gravity is down as we see it. A downward influence. Great, great questions. Keep them coming, keep them coming, keep them coming. If you got them. Thank you for asking that, by the way. And if I didn't answer it, give me another chance. Tell me what doesn't make sense, and I'll try to come up with another analogy. Okay, so when you positive accelerate, you're going in the same direction. Ooh, not necessarily. Okay, what a great question. So remember, direction means different things to different concepts. I can have a positive position, meaning that if I say, let's take an elevator, for example, and I say the lobby is 0. I define it. I say the lobby is 0. So if I'm on the first floor, I have a positive position. And if I'm in the basement, I have a negative position. So positive and negative can mean, where are you at? Positive and negative can mean, where are you going? So in other words, I might have a negative position, but be moving in the positive direction. So my position may be negative, but my velocity and movement may be positive. So velocity just means, where are you going? Where are you moving? What direction are you moving? And that could be positive or negative. Now let's take acceleration. Positive acceleration means that a positive leftover force is changing your velocity. It's speeding you up or slowing you down. So when you are positively accelerating because of a positive force, think about how a basketball, let's say I have a basketball and here's the floor, and the basketball feels a positive force from the ground, and that positive push from the ground is going to be more than the planet pulling down on it. How do I know? Because the planet doesn't pull the ball through the ground. When the ball comes in contact with the ground, it's going to slow down while it goes down as it compresses, and then it's going to speed up as it comes up. Both of those things happen because of a positive unbalanced force. Therefore, both of those things were positively accelerating. The basketball positively accelerated while it slowed down moving down, or slowed down while moving in the negative, and then it changed direction and then sped up while moving in the positive, sped up by going up. So the basketball experienced positive acceleration in both of those phases. Same thing, when I bounce the ball in the air and then it leaves the ground and goes up in the air, the ball will be negatively accelerated when it's going up and when it's coming down. But think about what's happening when it's going up. It's slowing down as it goes up. Why? because it's negatively accelerating because of gravity. Gravity is slowing it down as it goes up, changing its direction, and speeding it up as it comes down. So the ball was negatively accelerating in both phases, slowing down as it goes up and then speeding up as it comes down. When the ball bounces on the ground or on the court, the ball is going to be positively accelerating the whole time, slowing down as it goes down and then speeding up as it comes up. Okay? So when you're positively accelerating, are you going in the same direction as the force? Not necessarily. You are going in the same direction as the force when you're slowing down, like going into the wind. But you're going to be going, well, you're going to be going in the opposite direction as the force. Your movement will be in the opposite direction as the force when you're slowing down. And then your movement will be in the same direction of the force as you speed up. Great question. Let me know if that answered it. So in other words, instead of saying accelerate and decelerate, say speed up or slow down. Because if we say accelerate means to speed up, then we lose track that acceleration doesn't necessarily mean to speed up. Acceleration just means to change your velocity. And sometimes when you're traveling 65 miles an hour and you slam on the brake, that's acceleration. You're accelerating because you're slowing down, you're changing your velocity. Now, if you always keep positive in front of you, in other words, wherever you go, then slowing down while you're traveling in the positive is negatively accelerating. So sometimes we can say negative acceleration if we keep positive, always looking forward. Let's see. Is it similar to eccentric work? Yeah, that's why. Now, keep in mind, this is we're keeping this very simple here, okay? But that's actually why they'll call it a negative, but it's not the whole way down. But if let's say we're doing a bench press, and remember in 310, I taught you to tell me when something's greater than something else, speeding up, slowing down, constant velocity. So it's called a negative, but that's only true when we're talking about speeding up the downward motion because your muscles let off and you're letting gravity be greater. Gravity is a negative force, so speeding up the motion down is a negative. However, when it comes time to slowing down the motion down, it takes a positive unbalanced force to do that. So when it comes time to slowing down the motion while it's traveling down, that's a positive acceleration that the bar must feel from your hands in the positive direction. And so if we want to apply it to lifting weights, the bar would be negatively accelerating, speeding up as it comes down. The bar would be positively accelerating, slowing down as it comes down. The bar will continue to be positively accelerated as we speed it up coming up. And then the bar will negatively accelerate when we slow it down going up. So the negative acceleration is going to be at the top part. That's when you let gravity be greater. And the positive acceleration is going to be at the bottom part when your muscles have to be greater, pushing up. I hope that helps and clarifies that. But that's where the word negative came from. You're doing some negatives. But in mechanics, it's truly only negative when gravity is responsible for the acceleration. That's the negative unbalanced force. You're welcome. Thank you for your question. I think I said it on the lecture this morning, but remember, no class, no new material Friday, and nothing during the break, as per university email during the break. Okay. Rodney, that is way too. You have to be specific. You have to have a specific question, man. Run through the terms. That's way too general. Is there a specific term you want me to talk about? Is there a specific term you want me to redefine or go over? One of the reasons that's kind of an unfair question is off the top of my head, I don't want to say a few things that I can remember, and then you write that down, and then quote me on that, and then I forget some, and then you're like, you didn't tell me in our review, right? So that's how I fuss at myself. I point and I wag my finger. So that kind of question is kind of open ended. Can you tell me about the history of the Earth? It's a very open ended kind of question. So if there are some specific terms you want me to clarify or go over for you, I have no problem with it at all. But basically asking me to do a review of everything you're going to need to be accountable for, I can't do that because there's no way I'm going to be able to cover everything. And then whatever I forget, then it becomes my fault that I didn't remember to tell you to know that. So just I can tell you that I didn't waste your time with any of the lectures. So all of the terms that are in the lectures are of importance, and you need to know them. So to answer your question, I'm never going to ask you about or teach you about stuff that's wasted time. So they're all there, buddy. Just like the finger wag. That's how I fuss at myself. I wag my finger at myself in my head. Hey, did I hear a dog barking outside? Hello, yup yup dog. Trayson, did you hear that? Hmm. All right, guys. 8 more minutes. So specific questions, if you can, or clarifications. Try not to ask like general things. All right, guys, last call for any questions or clarifications. Oh, all right, guys. Y'all have a good one. Hit me up, email or text me if you have any specific questions. Bye.